This is worksheet number 2 for the academic decathlon for 2025. Let's go. Quantities. So now we're going to deal with worksheet number 2. Let's look at our prerequisite skills. Unit conversions. A large rattlesnake has a fang that measures 15 centimeters. Express the fang length in millimeters. Okay, so we have this little saying that Mr. Mack likes to use. King Hector died, unfortunately, drinking chocolate milk, where K stands for kilo, H stands for hecto, T, maybe K, hecto, deca, with a K or a C, units meaning meters, liters, grams. Now these are the easy, deci, centi, milli, all ending in I, meaning small. Okay, so if we start with centimeters, so that's important to know what we start with. We're starting with centi and we want to move to milli. So if I move from milli or centi to milli, I'm going to go this way. I'm going to go to the right one. So if my number is 15, I'm going to take that decimal point and I'm going to mirror that movement. So 15 centimeters is going to equal 150 millimeters. We okay with that? So 150 millimeters. And now we're going to move to meters. So now we still are starting with centi, because that's our number, centi. And this time we're going to go to meters. So this time we move to the left to my meter unit. Not this M, that M represents milli. So meter. So this time I have my 15, I have my decimal point, but I'm going to mirror the movement. I'm going to move it 2 places backwards to the left. And so if I start with 15 centimeters, I'm going to end up with 0.15 meters. 0.15 meters. All right, kilometers. So now let's do kilometers. So let's erase this. Hold on. Let's erase this part. We're still starting with centi. I gotta go back to my pen. So we're still in centimeters, and this time we're going to kilo. So centi. So we go 1, 2, 3, 4, 5 places to the left. So 5 places to the left. We have my decimal point is there. So 1, 2, 3, 4, 5. And each of these equals a 0. So 15 centimeters is going to equal 0. We have 1, 2, 3 loops. 1, 2, 3 loops. And then my 15. So each of these loops gets a 0. So we have, that's going to equal 0.00015 kilometers. And inches, oh, okay. Inches, you're going to need to know, it's probably going to be approximately 5 centimeters. No, oh, inches, sorry. It's going to be 5 inches. No? Yeah, 5 inches. I bet you it's approximately 5 inches. Yeah, I think 3 centimeters is equal to, approximately 3 centimeters is equivalent to 1 inch. But we can do this. Hey Siri, how many inches are in a centimeter? 1 centimeter equals 0.39 inches. 1 centimeter equals 0.39 inches. Let's do it in. No. 1 centimeter equals 0.39 inches. So if we have 15 centimeters, we're going to multiply that by And that would tell me 15 times 0.39, which gives me 5.85. 5.85 5 inches. And that gets the approximation. The other way we can do that conversion is we have 15 centimeters. We do a conversion box. My conversion box, I got to get out of centimeters. So I'm going to write centimeters in the denominator, inches in the numerator. How many centimeters? 1 centimeter, 0.39 inches. That cancels denominator, and we ended up with 15 times 0.39 inches, like we did here, and we get 5.85 inches. All right, let's get into the worksheet. Your class is conducting a poll of the neighborhood. Together, you can canvass 6 households every 5 minutes. There are an average of 24 households per block. And how many blocks can your class poll in 2 hours? So 2 hours is how many 5-minute intervals? So I'm going to divide that into 5 minutes. Well, these are unlike units, so how many minutes are in 2 hours? Well, each hour is 60 minutes, so I have 120 minutes divided by 5 minutes, and that's going to give me 24 5-minute blocks. And if I can do 6 households, 24, what would we call those? Intervals? And if we take and we get 6 houses each interval, so we're going to multiply those together. That's 144 houses. And if there are 24 households per block, so we'll divide that by 24 houses per block. Okay, houses per block. 144 goes into 24, so that's 12 times 12, and that's 2 times 12. 12 times 12 is 144, 24 is, and we're going to cancel the 12s, we're going to cancel that, and so we get 6 blocks. So we would cover 6 blocks in the 2 hours if we conduct polls of 6 houses every 5 minutes. That's pretty efficient. The class next door wants to help with your poll. Working with this class, you can survey 5 blocks each hour. Okay, how many households can the 2 classes poll in 10 minutes? Okay, so if we can do excuse me, 5 blocks each hour. 5 blocks per hour, and that's going to equal 5 blocks per 60 minutes. So if we, so how many blocks? So 5 blocks each hour, and we're only polling in 10 minutes. So we're going to divide that by 10. So that is 1/2 in 10 minutes. So we can do a half a block. Okay, half a block, no? That's half a block. So there's 24 households per block, so 12 houses? 12 households? Class next door wants help working with this class. You can survey 5 blocks each hour. How many households can the 2 classes poll in 10 minutes? Well, this one, I think this is going to be 12 houses. And then I think we're doing at this rate. So that's going to be an additional 12. right? Because, I mean, you got 10 minutes, so this one's going to do 6 for 5, so that would be 12 for 10 minutes. And this one, I mean, that's the same rate, so maybe I did something wrong here. You can survey 5 blocks each hour. So, okay, let's do 5 blocks. So if there's 24 houses per block, so let's do it differently. Let's do this. So we have 5 times 24, and that's over 60 minutes. But I want only 10 minutes. Oh, I think I messed up here. I think that should be 1 block. My bad. I was dividing by 6. Divide by 6. I messed up. My bad. My bad. So we're going to divide by 6. Divide by 6. That gets me my 10 minutes. And that's going to be 4. So that's 20 houses. 20 houses in 10 minutes. My bad. My bad. It's okay. That's why taking your time is going to be important. Now, it is really about efficiency. How can you go fast without being wrong? What needs to be corrected in the following graph in order for it to not be misleading? Well, they have to align. So this is 1, 2, 3, 4, 5, and this is 1, 2, 3, 4, 5, and then this last lightning bolt should be up above this if this is going to be 6. So there's an uneven sizing of the pictograms. Yeah, that's easy. That's nice. Okay. Number 4, the coldest temperature recorded in the United States is negative 69.7 degrees Fahrenheit. And the hottest temperature recorded is 134 degrees Fahrenheit. Hottest temperature recorded in the United Kingdom is 40.3 degrees Celsius, which has a greater variation in temperature by how much? So we're going to plug in Fahrenheit and get an output of Celsius. So we're going to convert the United States to the UK. So we're going to do 5/9. Negative 69.7 minus 32, and that gives us 5/9. That's going to give us 0.7. That's 11. That's 101 degrees 789. That's going to be divisible by 9. So 101.7 divided by 9 gives us 11.3. So 5 times 11.3 times 5 gives me 56.5. 56.5. Negative 56.3 degrees Celsius. So negative 69.7 degrees Fahrenheit is equivalent to negative 56.3 degrees Celsius. Okay, now let's do the high temp. So we have 5/9 times 134 minus 32, which is 5/9 times 102. And now that doesn't reduce. I mean, 3 goes into both of them, so 5. This is going to be 3 because 3 goes in this 3 times, 3 goes into this 34 times. So we have 5 times 34 over 3. 5 times 34 equals, divided by 3 equals 56.6. 56.6 repeating degrees Celsius. And that was 134 degrees Fahrenheit. Okay, now they want to see which has the greatest variation. So the variation is 134, this is Fahrenheit, is 134 minus negative 69.7, which is going to be 134 plus 69.7, which gives us 0.7. 56.30,203. That's the gap between Fahrenheit. Celsius is going to be 56.6 repeating minus negative 56.3, and that's 56.6 plus 56.3, which is kind of 0.92, which is 102, yeah. No, 11. The United States, a greater variation. Oh, well, they wanted each one. Sorry. I did overall, where we were looking to do. Sorry, that was not the right way to do it. We're looking at the variation between hot and cold, which is a variation in temperature. All right, well, that's kind of... Well, maybe I didn't read it in that. United States by 27. Was that right? 27? Was that the... Oh, sorry. 27. It's not 27. Oh, wait, what am I in? I'm in... Oh, no. That's the high. That's the low. Oh, so... High, low. Okay, sorry. Yeah, I did a little bit, not a little bit, I did a lot of bit bad. I went comparative. So they want to know the variation in the US, so hottest to coldest. So US is going to be, that varied. Yeah. Now the variation. Yeah, I think I did it right. I did, oh, sorry, I got it. So 56.6 repeating minus negative 56.3. Yes, this is the, this is US, sorry. US is this. So that gave us 112.9 difference. And then if we look at Great Britain or the UK, yeah, sorry, not Great Britain, UK, the United. The differences in UK was 40.3 minus negative 27.2. There we go. So 40.3 plus 27.2, which gives us 0.576. And, okay, what's the difference between those two? 12.9 minus 67.5, which is 0.4. I don't have to borrow from there. I got to borrow from there, which is going to be 5 and 4, 45.4 degrees. No, still not. That's degrees Celsius. I don't know. I don't know what I'm doing wrong. All right, I mean, those were the extreme for US. How's temperature? 134 Fahrenheit. Plug in Fahrenheit minus 32 gives me 102. That was correct. Gave me 56.6. Let's take a peek. Let's see. Siri, 134 degrees Fahrenheit is equal to what in Celsius? Yeah, 56.6 repeating. Good. Siri, negative 69.7 degrees Fahrenheit is equal to how much Celsius? Yep. Negative 56.6, but that's okay. That's close. Okay. So Siri, hey Siri, what's 56.6 plus 56.3? 112.9, yes. Hey Siri, what's 40.3 plus 27.2? 67.5, yeah. Did I not do 40? High is 40. High is 40. Low is negative 27.2, yes. Okay. That's good. That's the gaps between the two. Hey Siri, what's 112.9 minus 67.5? 45.4. Yeah. All right. I don't know what I did wrong. Who knows? All those conversions are correct. Tell me where I made my mistake. I don't know. Goodbye, Siri. I don't know what I'm doing wrong. So you let me know how I'm misinterpreting that. But it says the U.S. has a bigger variation of 27 by 27.9 or 82.2. We're all in Celsius, so that variation, I don't know, in temperature. I don't know. 27.2. All right, well, there's 27 for Celsius. I don't know. Well, good luck. Here's our conversion boxes. This is our this is equal to 1. This is equal to 1. And that's how we convert in there. The work problems, yeah, those are interesting. Those are fun. And graphs, are units measured? Is the origin 0? Is it a pictogram? Are the axes labeled? Yeah, these are important things to take note of. Good luck. Tell me where I made my mistake on 4.